Hello everyone, welcome back to my channel. Today we will talk about Cloaked in Secrecy. Here's NGAD fighter's performance. Before watching the video, please like, comment, and subscribe my channel. While the manned centerpiece of the U.S. Air Force's next-generation air dominance, NGAD ecosystem remains draped in secrecy, and the competition to build it appears to be narrowing. A few general assumptions can be made about its configuration and capabilities. One area that still remains a real question mark, though, is its targeted performance. One can assume to a relatively assured degree that the NGAD fighter, although it really won't be a fighter in a traditional sense, will possess a number of unique traits and features. As it sits, Air Force Secretary Frank Kendall says each manned NGAD aircraft will cost hundreds of millions of dollars, and about 200 is the current targeted fleet size. The aircraft would replace the F-22 Raptor stealth fighter, which is being used to test NGAD component technologies in terms of force structure. But its mission would be considerably different. By every account, just as we have been pleading for many years, the manned NGAD aircraft will be optimized for range, payload, and low observability, stealth, non-extreme fighter maneuverability. Its mission to fight as part of a highly integrated, deep-penetrating team of systems over long distances reflects these qualities. Spectral warfare is also a key component of its overall design, among other cutting-edge technologies, which will likely be in the heavy fighter/interceptor size class or larger. While sacrificing maneuverability for range, payload, and low observability is largely a given, just how fast and high the NGAD combat jet will fly is something that still is in the realm of total speculation. The NGAD fighter should be a very slick design, featuring an elongated blended fuselage and wing configuration that lacks traditional horizontal and vertical stabilizers. This unprecedented tailless configuration would largely be due to the effort to maximize survivability via low observability, stealth, across a broad radio frequency range above raw maneuverability, but it should significantly lend itself to aerodynamic efficiency. The question of how fast this aircraft will be able to cruise, at what fuel consumption, and to a lesser degree, dash, is intriguing to ponder. Seeing as it will have to operate over longer distances with a much greater combat radius than current U.S. fighters possess, while holding all its fuel internally, the ability to cruise very efficiently will be key. Taking that a step further, considering the distances involved in transiting to and from target areas, being able to sustain supercruise supersonic flight without the use of gas guzzling and heat signature blooming afterburner could be a hugely beneficial capability. Not only would this aid in survivability in some respects, but the faster it can get to a place it needs to and perform its mission and return, the more sorties the fleet can generate. This is especially true for a small fleet of aircraft. The Air Force is currently planning to acquire just 200 manned NGAD aircraft, at least at this time. The F-22 is famously highly capable of supercruise. It was a core demand of the Advanced Tactical Fighter (ATF) program's requirements. What most people don't realize is that achieving supercruise for the Raptor still consumes a lot of gas, and it is usually relegated to short tactical dashes as part of its normal mission profile. The F-22 has a remarkably limited combat radius. It trades its extreme performance in terms of speed and maneuverability, as well as low observability for this. So while supercruise is highly beneficial to the Raptor's tactical prowess, the NGAD fighter could leverage it differently. What if supercruise could be achieved for long periods, as a way to speed up the time it takes to transit to and from its intended station, without a massive penalty in fuel consumption to go along with it? Dash speed is a different story, but it has issues that may negate some of the NGAD fighter's potential advantages. Traditionally, high-speed flight would turn what is a very stealthy aircraft into an unstealthy one on the increasingly critical infrared spectrum. High-thrust settings, especially the use of afterburner and skin heating due to friction with the air, is a major problem for higher Mach dashes. This is where supercruise can help, as it negates the need for afterburner. But higher speeds could be readily available with afterburner, or even with higher dry thrust settings if the next generation engine is capable of it. Once you approach Mach 2, skin heating becomes a major problem, at least traditionally speaking. Low observable skin treatments also are not known to be durable at high heat for sustained periods. Just ask the F-35 about that. The Raptor's coatings do seem to be less susceptible to those issues. Regardless, the Super Cruise sweet spot is somewhere around where the F-22 generally operates, above Mach 1, but well below Mach 2. It is publicly known that the Raptor can supercruise at up to Mach 1.7 and can hit Mach 2 with afterburner. It can theoretically go faster and has been tested up to Mach 2.1, but the speed on the jet is limited due to a wide variety of reasons. It is possible that advanced material science and thermal management systems, as well as coatings and countermeasures, could help cloak the NGAD fighter from infrared detection, or otherwise attenuate its thermal load even at higher speeds where skin friction would bloom the jet's infrared signature. We just don't know, but if that is possible, the aircraft's high sustained cruise speed and its survivability while in that part of its performance envelope could be something of a revelation. Another one of the F-22's most unique advantages is the altitudes at which it can operate in excess of 60,000 feet. This is on the verge of where a full pressure suit would be needed for aircrew. While the Warzone has discussed this unique ability for many years, it became headline news recently when, just as we surmised, it became clear that the Raptor was ideally suited to intercept and eventually shoot down the Chinese high-altitude balloon earlier this year, and other suspicious craft that followed. Raptors can hang around up there thanks to their huge control surfaces, high thrust and specially configured F-119 engines, and especially their thrust vectoring capabilities. Still, even for the F-22, maneuverability is highly diminished at those altitudes. So what about operating altitudes for the NGAD fighter? I think it's relatively safe to at least posit that it will have similar capabilities. Such a high perch offers critical advantages that are arguably even more important to the NGAD fighter than the F-22. It allows munitions, especially air-to-air missiles, but also air-to-ground weapons, to fly much farther than when launched some 20,000 feet below. Considering the threat environment the NGAD family of systems is being built to operate in, this will be key. Just remember, even the stealthiest aircraft is still vulnerable to detection, just at significantly shorter distances, depending on a huge array of factors. Regardless, sneaking through an enemy's air defense network is not always an option. It will become increasingly hard to do so as those networks, and their sensors, and data links that connect them, evolve and proliferate.